Hi guys, my name is Jeeth, and today I'm going to show you how to use Chroma, this new open source embedding database, to turn a PDF of your liking, whether that be a book, a financial report, an essay, poem, any data that you want in a PDF format, into something that a model can understand and use when it's building its responses. Chroma is pretty neat because of how lightweight it is. It kind of prides itself in only really having 4 commands, and it's pretty simple to use. Perhaps maybe not as easy when you're starting off right away, or if you haven't had as much programming experience. So I didn't see too many tutorials online, hence I decided to post this one. I want to make this short, sweet, and basically go over the high level of why this code works and make sure you understand exactly what's going on. So let's begin. First thing is I'm going to be using a book, 7 Habits of Highly Effective People by Stephen Covey. For this example, I like this book and I had the PDF. So our first step is basically going to be to take this book that's in a PDF format and convert this into text because yeah, we want the meat of this actual PDF. And in this case, in this book format, that's going to be the actual words in there, right? That's where our information's there. So that's what this loader.load function is doing. And as you can see, it's going to basically put all the words in this book, all the letters into one document of 762,000 characters or so. And keep in mind, this document, when I say it's document, it is of a document type, which is the specific format that we're kind of required to use, with the libraries we're going to be using in this tutorial. So I'm going to see that come up later on. That's the first step, but that's kind of a problem though, because going back to the drawing, now you have essentially one document with a bunch of information, right? Basically all the chapters in this book. And that's a problem because our prompt, right, whatever we're using as our large language model has a limit in terms of how many characters you can give as an input, right, even for training. And in our case, we know we have 762,000 characters, which it definitely cannot take. The way we get around this is by basically breaking this big document into multiple documents. In my case, it's going to be 963 documents specifically. It's going to vary based on your size. So we're going to kind of break this up into smaller documents and find the most relevant document for our prompt and put those into the model instead of putting the full thing, right? I'm going to go over the specifics of how that's done from a mathematical point of view later on, just super high level, nothing too technical. But what we're doing here is breaking up the data using the recursive character text splitter. Chunk size is how much you want each document to have. I kept it as like a default of 1,000. You can play around with this. And then chunk overlap, we don't want any overlap between the documents, hence it being 0. So that's what this 963 documents here means. That's why we have this right here. Let's keep moving along. Next up is Chroma, right? Really the meat of this video. Chroma is going to help us embed our data. So at this point in time now, we have a bunch of documents, 963 documents, right? But keep in mind, this is in English right now, or whatever language you're using. And the model doesn't really understand English, or once again, whatever language you're using. It understands numbers, right? Because it's built on math and statistics. So when we say we're making an embedding out of a document, what that means is we're converting this document of words into a matrix format of numbers that the model actually understands, right? So for all 963 documents, what Chroma is going to help us do is convert this into a number format that the model actually understands. And more specifically, looking at this data structure here, it uses a collection type data structure. And in this collection type, we're going to have actually 4 attributes. First is going to be documents. So what we're going to do is put all our 963 pages of documents of text into the documents attribute. Metadata, you don't really need that. If you want, you can put that in there. Same thing with IDs. IDs is required, unlike metadata. So I'm just going to assign it numerically. But if you want to retrieve it or do anything more fancy, then you can kind of look into that. There is a 4th column here called embedding. So if you're embedding your document into something other than, if you kind of want to use your own embedding mechanism, then you can do that by adding an embeddings column. I'm just going to use the default sentence transformer embedding function for this case. But you can, OpenAI has their own function. Facebook, I think, has their own function. You can kind of play around with that and see. I'm just kind of going to stick to the basics. So going back to the code itself, let me clear this drawing. What to do is create this new client. Like, this is boilerplate code, right? You just kind of have to do it. ChromaDB.client, just making a new client, creating a collection. I call this book. You can name this whatever you want. And from there, adding all the documents. And remember, it's a document type, it's not string. So for all my documents, all my text, I've called it here, I just want to put in all the actual page content, which is the actual strings for every single page, right? The actual meat of the book. From there, I want to numerically assign all the IDs. That's what this means. And I think we're good to go there. Next, we're going to import LangChain. So, I mean, this is going to be like a three-way thing, right? We have our PDF document, which is the actual data. We're going to have our embeddings done using Chroma. And then finally, we're going to have LangChain to basically connect the PDF document to the data we have. That's why we're using LangChain in the first place. So some basic boilerplate stuff to set this up. Large language model, we're going to use OpenAI's. Large language model GPT3, temperature, you can choose that. OpenAI API key, you can put that in for whatever you have. I have mine saved in the environment, hence why this is there, but you can just kind of copy paste it here. It should work just fine. And then in terms of loading the actual chain, we're going to put in our large language model, and chain type stuff is a general use case, which we're going to use. Next part, I think is pretty important to understand conceptually. At this point in time, in our Chroma document, in our data structure, we have a bunch of documents, and we have the embeddings, right? Which is the actual matrices that represent all of these documents of text, right? Of the actual pages of the book, and not actual pages, but whatever way it's kind of divided. At this point in time, we talked about how we can't put in all the documents at once. We're going to pick the most relevant one. The way this is done is actually based on the query. So whatever you ask the model to do, in this case, I'm asking, why should I put first things first? Putting first things first is habit number 3 in the book, which is why I asked the question, but that doesn't really matter. So how this is going to work is this query is going to be turned into a matrix vector, just like the embeddings, right? And what this collections.query is going to do is find the documents that are most similar in meaning to my prompt, right? So think of it like from a line point of view in like a 2D grid. I have this point, and I have, think of this, not the best color, think of this yellow as all my data, right? All my documents. What this collections.query is going to do is find in space, and it's actually something called cosine similarity. So this is grossly oversimplified, but I'm going to keep it like this to help you guys understand. It's going to find the points that are closest to my query. And in this case, it's n results equal 5. You can, if I pick more than 5, 10, then it's going to pick all these like that. That's how it kind of works. And it uses something called cosine similarity. It's not actually like this. You can use Euclidean distance. But yeah, at a high level, that's really what's going on. We're just picking the documents that relate most to our prompt. The idea being the documents that relate most to their prompt are going to best help us answer the prompt itself. So yeah, that's what's going on with collections.query, and that's why we kind of need Chroma in the first place. So looking at this output, you kind of get the IDs, which is what we assigned before. Embeddings, it kind of does this in the back end. We didn't put our own in, which is why it's none. And documents, these are the 5 documents that it determines is most similar to our question. So kind of look through these, read through this, you see first things first, high priority goals, which is what putting first things first means, putting your goals first. Like, I don't have to go too much into this, but that's why these documents have popped up, and you can see the distances. It's picked the distances that are the closest. So that's what all this means. Moving on, at this point in time, we've found the 5 documents that are most relevant to us, and we can adjust this number as we wish. From there, we need to kind of convert these, because this is text, right? I know this is documents, and this is a little confusing, but what this actually is just text, right? It's strings or a bunch of characters. So we need to convert this back into a document type, because that's what LangChain requires us to do if we want to import any documents of our choice. So what this fancy for loop, not even fancy, but what this, I guess, for loop, even though it seems redundant, is going to do is going to go through all the documents, go through all this text, and for each one of these paragraphs, it's going to turn that into a document type, with the page content being in the document type where all the meat of the data resides. That's what this is doing. So at this point in time, we have our final documents with the actual content that we want to input into the model. Final thing is actually using the function and connecting it together. So when I do chain.run, input documents are the documents that are relevant to the question we're answering. Question equals query. Query is the question we're actually answering. And all of that's going to be put into the model. And the output is putting first things first, means prioritizing activities that are important and contribute to your mission, blah, 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 blah. It's correct. So yeah, that at a high level is how you guys connect all these pieces together. specifically for Chroma. I did this tutorial because there really wasn't any tutorial online and the documentation was there and it wasn't bad. But for someone who kind of like to learn things visually, I think this is going to help out a lot of people. So let me know what you guys think below. Comment on any other topics you want me to make videos on. Comment on whether you want this to be more high level or more low level. And yeah, thank you guys so much for listening.